Students, you can mark your attendance in the chat box, then we will start a lecture, okay? So students, today we will revise unit 4, that is turning effect of forces. So you can open your book, page number 86. So first of all, we will discuss about like and unlike parallel forces. So what are like parallel forces? Like parallel forces are forces that are parallel to each other and have the same directions. So the first condition is must that the two forces, they are parallel to each other. What is parallel? Parallels are those lines that do not intersect at any point. So in the case of like parallel forces, the forces must be parallel and they also have the same direction, right? So if you take the example, see the example figure 4.3, weight of each apple. So as you see in the figure, there's a bag and all the apples they are placed and their weight is acting downward in the same direction. So you can see the direction is same for all the apple, right? So these direction, they have the same magnitude and also they are parallel to each other. You can see that they cannot these lines cannot intersect at any point with each other, right? So they are the basically parallel to each other. So this is an example of like parallel force. Then the next one is unlike parallel force. As by the name you can see that unlike mean they are not parallel to each other, means they are sorry, they are parallel to each other but their direction is not same, right? In this case also the condition is but that they are also parallel to each other but their direction must be opposite. So we can say that these are the unlike parallel forces. Both in unlike and like parallel forces, forces must be parallel to each other but it's vary in the direction. In case of parallel forces, the direction must be same, but in case of unlike parallel forces, the direction must be opposite to each other. If you see figure A, there is a stand and one apple is suspended with this stand. The weight of apple is acting downward, right? And there's an opposite force that is acting in a producing a string that is acting in the upward direction, right? Now you can see that these forces, tension and weight, they are parallel to each other but their direction is opposite. So as their direction is opposite but they are parallel to each other, we can call them unlike parallel forces, right? Similarly, you can see the figure 4.4. This is also an example of unlike parallel forces. If you see this bar, the one force is acting in the upward direction, right? This is a force F1. And the other force is acting downward. It is the force F2. So you can see that these two forces, F1 and F2, they are parallel to each other but their direction is opposite to each other. You can also take you can also compare this example with a seesaw. If the one person is moving in the upward direction, the other person on the seesaw will be moving in the downward direction. So both in both cases, they are the forces apply on each end. They are parallel to each other, but their direction is opposite to each other. Now, topic 4.2 is addition of forces. First of all, you must know what are the vectors. Uh, vectors are uh, Vectors are those quantities which has magnitude and direction, right? So forces, they are basically a vector quantity because it has magnitude as well as direction, right? So we cannot add them like an ordinary arithmetic rules. Like in scalar quantities, we are dealing only with a magnitude. So we can add scalar quantities like a arithmetic rules, like 2 plus 2 is equals to 4, 2 minus 2 is equals to 0, 2 multiplied by 2 is equals to 4, 2 divided by 2 is equals to 1. But in the case of vector, we cannot add a vector like a ordinary arithmetic rules. For that, we have to add the vector with the help of a head to tail rule. Because if there are two, three, or more than or many vectors they are given to us and we can add them, we have to use the head to tail rule. And the final vector, that is known as the resultant vectors, give the combined effect of all the vectors that are added, right? So for additional vector, we must know what is a resultant force. Resultant force is basically a single force that has the same effect as the combined effect of all the forces to be added. Like if you see that there is a force A in this direction and the other force is force B in this direction. So how can we add them? We can add them with the help of a head to tail rule, right? So first of all, we have to draw the first vector A. This end is known as the tail of the vector, and this is the arrowhead, which is known as a head of a vector, right? So first of all, we have to draw the first vector in the direction that is given to us, because then we have to draw this at second vector, or we can say we draw the second vector with the head of the first vector, right? This is the head of first vector, and we have to join the second vector with the head of this first vector, right? The tail of second vector must be joined with the head of first vector, right? So as in this case only the two vectors are given to us, so we can, to find out the resultant vector, what we have to do, we have to join the tail of the first vector to the head of the last vector, that is the vector B. In this case, we can add the vector, and this vector R basically was information about the resultant vector, which is the combined effect of the vector A and B. And this is known as the head to tail rule, right? Then you see the example 4.1. In this example, the vectors are given to us. Find the resultant of three forces. We have to find out the resultant vector R, or we can say that we have to find out F, right? Of three forces, the force one is given to us, that is 12 Newton along x-axis. So we call this force as F1 is equals to 12 Newton along the x-axis. So you can say that the magnitude is given, also the direction is given, that it's lie along the x-axis. The second vector is 8 Newton making an angle of 45 degree. So we can say this vector as F2, which is equals to 8 Newton along 45 degree with x-axis, right? And 8 Newton along y-axis. So we can call this vector as F3, that is 8 Newton along y-axis. Sorry, y-axis. So as you know that we cannot calculate the Newton with the help of measure the Newton with the help of our scale. So first of all, we have to set any scale. So here the scale is taken as 1 centimeter is equals to 2 Newton. You can also take a 2 centimeter, because you can this is a table of 2, so you can also use the 2 centimeter or 4 Newton. 1 centimeter is equals to 4 Newton as well. So if we take set a scale as 1 centimeter is equals to 2 Newton, so what it will be, as 12 is equals to, if you multiply 2 by 6, you will get the 12 Newton, right? So if I take this 2 as a 2 Newton, so it will be equals to 1 centimeter, and 1 centimeter multiplied by 6, you will get 6 centimeter, right? So the scale for F1 is 6 centimeter, right? 6 centimeter. for case F2 is 8 Newton. So 8 Newton is equals to, if I write 2 Newton multiplied by 4, right? Because 2 into 4 give us 8. 2 multiplied by 4 is equals to 8. So I can set 2 Newton is equals to, this 2 Newton will be equals to 1 centimeter, right? As it's, we have set the scale, right? So I can write 2 Newton 2 Newton is equals to 1 centimeter. So we will get this force F2 is equals to 4 centimeter. Then similarly for F3, it's again the 8 Newton. So I can multiply 2 Newton by 4, which is also equals to 4 centimeter, right? So F1 is equals to 6 centimeter, F2 is equals to um, 4 centimeter, and F3 is equals to 4 centimeter, right? So what we have to do, we have to take the scale and we have to draw all three lines along with their given angle. Then the final resultant vector, if we just find out this magnitude, we will get the resultant force, right? So we have all these, we have to add all these vector, and this resultant vector basically give us the magnitude of all these three vectors. Then we have to measure this angle with the help of protractor. So this angle basically gives us the direction, that is 37 degree, or also as we have, let's say the magnitude of this vector is in centimeter. So again we have to convert this centimeter into meter. So what we have to do, we have to just multiply it by 2 Newton per centimeter. So centimeter will be cancelled out with centimeter, and we will left with the magnitude in Newton. So in this case, in this way, we can add all the three vectors with the help of head to tail rule. So 4.3 is resolution of forces. First of all, we have to know what is resolution. Resolution is basically when we split something into its components. So here is the resolution of forces. So what we have to do, we have to split the force into its uh, perpendicular components. What are the two components of force? It will be Fx that lie along the x-axis, and the second one is Fy that lies along the y-axis. So this is basically the resolution of forces. So in this topic, we will see that how we can resolve the force into its perpendicular components. So perpendicular components are basically x component and y component. So first of all, we have to consider a force F representing by line OA making theta with x-axis as shown in figure 4.b. So here the vector F is given to us, uh, right? And it is making an angle along the x-axis. So, and we name this as OA. Now we have to split this vector into its perpendicular component. For that, we have to draw the line over here along the x-axis that we have to represent by fx, right? And fx, and then uh, this is fx line, right? Then we have to draw the line on a vertical component, that is a y component, that is fy. So in this way we know that this f is basically a resultant force. Now we have split this component into fx and fy. So this fx is basically lying along the x-axis, and we name it as a OB. Then fy that is lying along the y-axis, we name it as a BA, right? So this F is basically the total effect of Fx and Fy. So we can write it as uh, OA that is equals to this F, right? Is equals to OB. OB is equals to the Fx, right? And BA that is equals to the Fy, right? And this BA is the FY. So basically OB, BA, or we can say that FX and FY, they are the perpendicular components of force, right? The one component is lying along the x-axis and other component is lying along the y-axis. So there's a side information, some trigonometric ratios. So first of all, we have to know what are the trigonometric ratios. If you see the right angle triangle, so the ratio between any two sides is known as the trigonometric ratios. So in case of right angle triangle, we know that there are the three ratios. One is sine theta. Sine theta is perpendicular over hypotenuse. Here the perpendicular is BC and hypotenuse is equals to AB. So we can write BC by AB. Then we have cos theta. Cos theta is perpendicular over hypotenuse. So base over hypotenuse. So base in this right angle triangle is AC and hypotenuse is again the same, that is equals to AB, right? Then third one is tan theta. Tan theta is perpendicular over base. So perpendicular is BC and base is AC. So these are the three trigonometric ratios that we have must know to resolve the to find out the fx value of fx component and fy, right? So if you see the figure 4.7, we have draw this x component and this y component. So now by using the trigonometric ratios, we will find out the value of cos theta and sine theta. Cos theta is equals to perpendicular over, base over hypotenuse. So you can see that here the base is fx. So we can write fx over here by hypotenuse, that is equals to this f. So cos theta is equals to fx by f. Okay. And if you see that the fx is equals to this OB, right? This OB is equals to fx and f is equals to this OA. So this is the value of cos theta. Now, similarly, we can also find out the value of sine theta, as sine theta is equals to perpendicular over hypotenuse. So if you see the figure 4.7, you can see that the perpendicular is AB, that is equals to Fy, and hypotenuse is equals to F, that is equals to OA, right? So we can write as sine theta is equals to Fy by F is equals to BA OA. So if we, so with the help of cos theta and sine theta, we can find out the value of fx and fy respectively. So with the help of cos theta, we can find out the value of fx. What we have to do, we have to find out the to find out the value of this fx, we have to move this f on the other side, as f is dividing with fx. So when it will be go on the right hand side, it will be multiply and we will get the value, that is fx is equals to f cos of theta, right? So this is the value of x component. Now, if you see sine theta, with the help of sine theta, we can find out the value of fy. So this, as this f is dividing over here, when it will go on the other side, it will be multiply. So with the help of this, we can find out fy is equals to f sine theta. So these are the value of fx and fy, right? So basically, with the help of these trigonometric ratios, we have we have find out the value of x component and y component. As x component lies along the x-axis, so it is equals to cos theta, and y components lie along the y-axis, which give the perpendicular to us, so it is equals to sine theta. So in this way, we can remember these ratios easily. So if you see the example 4.2, you can easily solve if you know the value of fx component and fy component. So a man is pulling a trolley on a horizontal road with a force of 200 Newton. So the force is given to us that is equals to 200 Newton, right? Here we have write the force that is equals to 200 Newton. Making 30-degree with road. So this 30-degree is basically the angle. So theta is equals to 30-degree. Find the horizontal and vertical components of its force. So what we have to do, we have to find out the um, horizontal and vertical components. So what are the horizontal and vertical components? They are basically fx and fy. So as for fx, we know the formula that fx is equals to f cos of theta. So we can all the data is given to us. We have to simply put the values over there. So F is 200 Newton. We write 200 cos theta is 30-degree. With the help of calculator, we first of all we have to find out the cos 30. So cos 30 is equals to 0.866. So we have to multiply 0.866 with 200 and we will get 173.2 Newton. So this fx component is also x component of force. The unit must be Newton. Okay. Then we have to find out the uh, fy component, that is fy is equals to f sine theta. So f is given to us and theta is also known. So what we have to do, we have simply put the values. For f, the value is 200 Newton. For theta is 30, so it will be sine 30. First of all, we have to calculate sine theta with the help of calculator, that is equals to 0.5. Then we have to multiply this 0.5 with the force, that is 200 Newton, and we will get 100 Newton. So these are the two components that are easily find out if we know their values, right? So that's the horizontal and vertical components of pulling force are 173.2 Newton and 100 Newton respectively, right? So these are the values of fx and fy. Okay, now the next topic is determination of force from its perpendicular components. Now, as we know that we have find out these perpendicular components that are fx and fy. Now we will find out the magnitude of force and direction with the help of these perpendicular component. For this, again, we have to consider the same figure that we have discussed earlier in 4.7. So first of all, we know that this is the force, and we resolve this. We have already know how to resolve this force into fx and fy component, right? We have just see the name over here. O r is equals to f, and o p is equals to fx. Then p r is equals to fy. So with the help of head to tail that we have already used in previous topic, that is equals to OR is equals to OP plus PR, that is equals to F is equals to Fx plus Fy. So how we can find out the magnitude of force? For that we have to know the Pythagoras theorem. So Pythagoras theorem is equals to hypotenuse whole square is equals to base square plus perpendicular whole square, right? So here we apply the Pythagoras theorem. OR is basically the hypotenuse. So we write over OR whole square, that is equal to OP. OP, that is the base, and PR is the perpendicular. So we have to take the square by following the Pythagoras theorem, right? So with the help of figure, you can easily know that OR is equals to f, right? So we place over f over here. OP is equals to fx and PR is equals to fy. So we have to, so it will become f square is equals to f square x plus f square y. Now to find out the value of this f, what we have to we have to do, we have to take the square root on the both side, right? So by taking square root, f is equals to under root f square x plus f square y under root. So this is basically the magnitude of force that we can find out by using this Pythagoras theorem, right? So the next step is that with the help of these perpendicular components and with this figure 4.8, we can find out the direction of the force. To find out the direction, we have to use the tan theta, right? Tan theta is equals to perpendicular over base. So here the perpendicular is PR, so we can write PR over here, and OP is the base, so we can write over here OP. So PR is equals to Fy and OP is equals to Fx. This is the value of tan theta. As the direction is given by the with the help of angles, so we have to take this tan on the right side. So for that, if we move this tan on the right side, it will be theta is equals to tan inverse, because it's here it is tan. When it will be go on the other side, it will be 1 by tan, and 1 by tan is equals to tan inverse. Okay, because 1 by tan has a power of 1, and 1 when it will be go on the in the numerator, it will be -1. So theta is equals to tan inverse Fy by Fx. So in this way we can find out the direction of the direction of the force, right? So if we know the Fy and Fx component, we just simply put the values and take the tan inverse of this value, and we can easily find out the direction that is equals to theta. So for magnitude, we have to use the formula F is equals to F square x plus F square y under root. And to find out the direction of this magnitude, we have to use a formula tan theta is equals to tan inverse Fy by Fx. So this is the lecture for today. If you have any confusion in this lecture, you can ask me now. Otherwise, you can leave the meeting. Okay. Yes, students, you have any question in this lecture, then you can ask me. Otherwise, you have to leave the meeting.